Okay, this video is on the fractions quiz, solving this problem. So it might be a little difficult to figure out what this is initially, but what this is the fraction 135 over 7 divided by 45 over 63. So it's what is it in lowest terms? So the first thing I'm going to do, I like to write these out as multiplication problems. That's easier for me to understand. So what we have here is 135 over 7 uh, divided by, let's get the divided by symbol, 45 over 63. And one trick always to remember is that to turn this into a multiplication problem, all you have to do is find the inverse of this or flip this over. So the multiplication problem is going to be 135 over 7 times 63 over 45. Now the next thing we do is prime factorization. Remember to find, we want to list all the factors of these, and then we'll be able to cancel some out. We can cancel similar ones on the top and bottom. So one thing right away is if you are an expert at your timetables, I see this immediately, and you can always check this with a calculator. 63, what is 63? Well, it involves 7. It's 9 times 7. So 9 times 7 is 63. Aha, verified. Okay, so this is the same. So let's start breaking these things up actually. I also Googled a list of prime numbers, and this gives you the first 1,000 prime numbers, and this should help you. It should help you, first of all, to recognize if any of these are prime. Is 135 on there? I don't see 135. There's 131 and 137. So we know, well, especially 135 can be broken up by 5. So we'll divide that by 5 and see what that is. We can use a calculator for that. But so we'll see what those factors are. So let's start breaking these up. So I already said 63 is 7 times 9. I knew that. And then 9 is 3 times 3. So let's look at these. 135, well, I just said, because there's a 5 at the end, we know it's divisible by 5. So you want to look for little tricks like that. Like if it were even, you could divide it by 2. If there's a 5 at the end, you can divide it by 5. So 135 divided by 5. And if you don't recognize what it's divisible by right off the bat, just try a few things. Try, the numbers 2 through, if it's odd, try 3, 5, 7, 11. Just try some numbers and just check your prime list. And it's not prime, so it has some factors. So we just said 27 times 5 is 135. And what is 27? Well, is 27 on our prime list? No, it's not. And, again, if you know your times tables pretty well, what is 9 times 2, or 9 times 3 is 27. So we'll break this up again into its prime factors. So 9 times 3, if you don't believe me, divide that by 9, you get 3, right? So 135 is the product of 9, 3, and 5. And you can check that on your calculator if you don't believe me. And then that's over 7, and 7 is prime. Okay, so then that's multiplied by 63, we just said was 9 times 7, which 9 is 3 times 3. So 3 times 3 times 7. And then 45, again, that's a 5. So you can divide it by 5, if you know your times tables well, which you should. This is 1 5 short of 50, so that's 9 times 5, which is 3 times 3, 3 times 3 times 5, right? So we see a lot of common factors. So a lot of this is going to cancel out. So we can cancel these and these. So let's go ahead and hit backspace and cancel those already. And well, hey, the 7s cancel out, right? So cancel that. This can be a 1, this can be a 1. This 5 cancels out with the 1 up here, so that could be a 1, right? So what does this equal? Well, it looks like 9 times 3 because everything else is 1. So that's just 27. And if I didn't make any mistakes with my factoring and my multiplication, that should work out. So I'm going to show the answer here, 27, exactly. So again, a quick recap is we had this problem. We turned it into a multiplication problem because that makes it easier because you just multiply the top and the bottom together. But you can also cancel out like directly factors on the top of the bottom. And then to factor these, well, we first checked our prime list to make sure none of them were actually prime. Just Google list of prime numbers, you'll get that. And then, if you're savvy with your multiplication tables, you'll recognize things like 63 is the product of 9 and 7, and 45 is the product of 9 and 5. And then we're also suspicious about numbers that end in 5 because those are always divisible by 5. So if you have a number, anything that ends in 5 is divisible by 5. So we just divided that by 5. We got 27. And that's actually a number we recognize with our multiplication tables. And we checked our prime list, so we know it's not a prime number. And then you just cancel out terms on the top and the bottom, and you're left with something simple. And that's 27. And that is how you turn this into its lowest terms.